Good afternoon, evening, and morning, depending on where you're at. I broke CERN. Why do I have an echo? What did I do? Oh, I have a stream up. Never mind. All right. Get that bug out of the system. Yeah, apparently I broke. Val's probably sleeping because he was up much earlier than he generally does. And on Just Show, if you missed it, he did a great job. There he is. I'm proud of my little buddy, my female friend. So apparently CERN is broken, but we already knew that. Like, we knew CERN was broken, but now it's officially broken. They just don't want me to talk about it. They saw the night show and they're like, nope. So anyways, I wanted to do a quick PSA for all my Midwesterners like myself. We have a pretty incredible storm coming that they're warning of for the Michigan, Ohio, Indiana, Illinois, Wisconsin area. So be prepared for that. It's supposed to have some blizzard-like conditions, a lot of snow, and some really cold temperatures. Some places -30. So make sure you're taking appropriate precautions. It's supposed to hit on, like I said, Thursday, Friday into Christmas Eve. So it'll make travel a nightmare. So just be aware, be prepared, but you should always be prepared. Your forecast is improving. Ours got worse this morning. We got a weather alert and all that garbage. So ours is deteriorating, but hopefully it stays north and pushes through. But yeah, we're gonna have to stay warm. It's pretty cold here too. Yeah, it looks like we're gonna get that low pressure's right over Michigan at this point, projected. Looks like we're gonna get smashed. Winter Storm Elliott could bring blizzard conditions and heavy snow. So that's Michigan. We're used to it. We'll be all right. Right now it is 23 and my location. Where are you at, Belandris? You're in Wisconsin, right? If I remember correctly. Oh, you're in Utah? Okay. Well, that's good, Val. I hope you guys had a good time, for real. Sorry we took a bunch of it. Hopefully you got to still spend time. So, I guess I can share without too much doxing of myself. So it doesn't look that bad from the radar perspective, but I don't know where they say this is coming from, but Looks like we have some out here. That must be what's coming. And I just assume you guys can see that. So, yeah, there we go. Your daughter's in Wisconsin? Gotcha. Yeah, I thought for sure he was in Belindres was in Wisconsin, but we can build one. He'll give me a reason. Hold 1 second. Sorry. Sorry, the heat just kicked on, so I had to close the door so I didn't have the background. There's still probably a little bit, but I'm not gonna freeze for you. So yeah, it looks like there's a mess coming over the West Coast there. So just a quick PSA. So let's get rid of that. And we'll go back to CERN. Okay, does anybody know anything about CERN or much about CERN? I'm sure everybody's heard of CERN, correct? It is a requirement. Hit the like button. Don't make me send that fine lady Val after you. I agree, but that's tonight. That's tonight. We're going to talk about the science today. Yes, pretty much. And then in the night stream, we'll go into conspiracy. So I had all kinds of tabs open from CERN itself because the best information is generally the source. Yes, that's where my partner in crime comes in this evening. Fine, Digger. Fine. You might learn something though. So what is CERN? So CERN is a giant ring of a particle accelerator that accelerates small particles and slowly narrows the beam so that they intersect. When they intersect, they have them intersect and collide. That's why it's called a collider, or and hit each other. At that point, they do different things, and we're able to observe several things. Yeah, I agree with that. Yeah, it's long. Let me show you. Like I said, I had this all prepped, and then CERN decided to die. So. I'm trying to get a good picture of it. So many people think that CERN is like the only one. There are several different particle colliders. CERN is just the highest energy and the largest. Hey, what's up, Lieb? Oh, I didn't say hi to everybody. That's what I missed. What's up, Mighty Meat? Breaking CERN. Digger, good to see you that YouTube fixed your shadow ban. What's up, Vicky T? Yep, broke it and proud of it. Goodbye. Hey, Linda. Nice to see you. Belandris, what's up, buddy? And I think I got everybody. Levy, what's up, buddy? All right, that's done. It is 16.56 miles in circumference, or 26,659 meters. For our non-freedom unit folks. So there's actually one at Michigan State University, close to me. MSU, if you're watching, I would happily come visit. I'll probably make that happen. I just got to reach out to the right people. I'm trying to get a scale picture. So you guys can see how big this thing really is. I guess we can. So this isn't technically to scale, but this is Geneva, Switzerland. So it intersects through Switzerland, and most of it is in France. So it takes up quite an area, and it is underground. What's super weird? I missed something. So it's underground, and it's pretty insane. So this is the small. I wish I could find a picture that I'm looking for. Yes, it could. Stop it, Forbes. Stupid. So this is probably the best we're going to have. So this is the CMS Allison Atlas. Those are the sensors we'll be talking about. LHGB. So it is a giant tube. Hey, what's up, Just Dawn? I was just saying that. Yeah, I hope not. Didn't they learn anything from Twitter? We're gonna find out eventually. Hopefully. Yeah, CERN's still down. So we'll go back here. So it was built to find the God particle, or the Higgs boson particle. They actually found it pretty early on. It was a theoretical particle. And they are still not at full operating efficiency. So they have to pump more power into the system. But it's a step process, and they have to completely rebuild sensors and stuff like that, because it's a pretty violent process. Is Dance in here? Okay, Dance. Whenever you're ready, buddy. So they found the Higgs boson particle. Sorry, I'm just reading because, like I said, CERN stands for Conseil Européen pour la Recherche Nucléaire, European Center for Nuclear Research, and it is French. CERN has spent over $10 billion over the decades looking for the elusive particle. This discovery put CERN on the front page, yet most people still have no idea what scientists at CERN actually do. I love you, Levy. So inside CERN, and like he said, dancebikerdance is going to join us today. He'll join us here shortly. So CERN has been around since the 1950s. Recall at the end of World War II, Europe was a mess and its scientific community in shambles. Most of European scientists, especially in Germany, fled for the U.S. with Operation Paperclip. Scientists in the U.S. Had taken the lead in physics. In 1949, French quantum physicist Louis de Broglie proposed that Europe try to recapture its scientific glory by creating a multinational atomic physics lab. South America, are you... I feel like Valhalla is like talking to somebody else because he keeps putting in random things that make no sense, or he's trying to distract me. Okay, cool, good. Fed, did he get his stuff back just on? A few years later, CERN was born just outside of Geneva. The founding 12 states included Belgium, Denmark, France, West Germany, Greece, Italy, the Netherlands, Norway, Sweden, Switzerland, the UK, and Yugoslavia. As of 2014, 21 countries, including Israel, Poland, Finland, are CERN members. Each one gets 2 spots on the CERN Council, the decision-making body, but a single vote on such decisions. CERN's Director General Rolf Hauer, in 2014, functions as the leader. So we have a lot of international cooperation, and that's one of the things that I do enjoy is international cooperation. I think we need to... Hey, what's up, Alec Granger? Yeah, that's for sure, Digger. They all came over this way. So the United States is not a member state, or not a member, but an observer state. That is one that can attend meetings and get info, but not vote on certain matters. And of course, 531 million plus, they've put in a lot of time and research and money into a lot of things. So I feel like we probably should have a voting spot, but we're paying for a lot of it. Our universities are studying a lot of the data, and we're providing a lot beyond the monetary 531 million. But it's Europe's project. Let them have it. Like I said, so there's been a proposal to build one in South Texas. There are also smaller colliders we do pay for most things. Where is that? Oh, I think he's here. Good distraction. What's up, buddy?
Hey, good to see you, mate. How you doing? Is sound all good?
Oh yeah, I'm great. Yep, you're coming through loud and clear for me. So.
All right. Well, first of all, hello to everybody in the chat and Valhalla. Good to see you all. And I'll let you crack on. Obviously, I'm listening in while you're doing, and then we can have a chat about all this stuff. Thanks for having me.
Yeah. Thanks for coming on. So, do you know much about CERN? Like, is that kind of your wheelhouse or not really?
Just little bits. I've got a few little things to share about it later. Some comical stuff as well. But yeah, we'll talk about it because I've got some questions that you might know that I don't know to do with the types of particles they smash and things like that. But yeah, gotcha. I don't know a whole load, but I have an interest in it, so we'll have a chat in a bit. But yeah, I'll mute myself for a bit and let you crack on with this article.
Okay. So CERN's job was to find out how the universe worked. No big deal, right? Scientists decided the best way to accomplish this monumental task was to build giant machines that slammed subatomic particles into another. The hope was that these so-called atom smashers would give researchers a glimpse back in time. Accordingly, CERN began building its first accelerator in 1957, the synchrocyclotron, which is an awesome name. While it crashed and smashed its way toward 33 years of service, CERN now operates several accelerators and one decelerator in a building complex that straddles the Swiss and French border. The cost of these experiments is spread over the member states, mostly the U.S. It has 2,400 full-time employees, 1,500 part-timers, 600 institutes and universities were allowed to use its facilities to start unraveling a variety of mysteries, such as antimatter, black holes, and the events that occurred a split second after the Big Bang. For what it's worth, I don't subscribe to the Big Bang Theory. Over 10,000 scientists from 113 countries, half of the particle physicists on the planet, stop by CERN for research every year. And CERN, we're going to talk major crap about you tonight, but if you ever want to invite me, I would be happy to accept that invitation.
I think you may have burned your bridge there.
Yeah, I'm sure I did. I'll go up to London, East Lansing, and Michigan State. We'll be all right. People work at a variety of jobs, including engineers, experimental physicists, and even accountants, of course. I mean, there's a lot of data scientists, too. They have incredible banks of servers and storage for when they get a dump of information. So, first crack at the position, blah, blah, blah. At the heart of CERN is the world's largest and most powerful accelerator, and that's what I was talking about before. There's been propositions by the Russians, of course, that want to be difficult, and they definitely have the space to be able to do it, and could build a bigger one. And there's also been propositions by China, who of course wants to get into the game. So, smasher called the LHC, so big that it is its own article. The LHC is made of 17-mile, 27-kilometer ring of superconducting magnets and a series of accelerators that shoot high-energy particles through an apparatus like a bullet through a gun. It's 328 feet, 100 meters below ground, and two beams of protons in opposite directions. So basically what it is you have superconducting magnets, and they suspend it, and it continues accelerating around. Well, I'm trying to, Dwayne. We'll get there, buddy. So it's so they continuously shrink the beam until they collide. Atoms are very small. We don't have a lot of the technologies to. A lot of people, and I get a lot of questions about it. They're like, "Oh, will they just shoot one at one?" No, they're shooting thousands, if not millions, of atoms, protons at each other, and just hoping that some of them hit. So it's not just a one-on-one. So it'd be cool if they could do it. At top speed, particles smash into each other each one at 99.9999991% the speed of light. Every time protons smash into another, it creates a complex spray of other particles. Many of those last very short times. And they follow this trail of subatomic breadcrumbs. There are several detectors, and they just added more. The major ones are Atlas, 148 foot long and 82 feet high, helped find the Higgs boson. Atlas is half as large as the Notre Dame Cathedral and weighs as much as the Eiffel Tower. CERN uses Atlas and other detectors, ALICE, CMS, LCHB, LCHF, to study stuff you only read about in sci-fi books, such as if other dimensions exist, what type of unifying force might be in the universe, and if there's evidence of dark matter. I think dark matter is a cop-out. I don't believe that it exists. I think they don't know. And it's a catch-all. Only 2 detectors, Atlas and CMS, were devoted to solving the Higgs boson. All experiments at LHC are distinct and run by a worldwide collaborating team of scientists. Like I said, the data that comes out is incredible. I hope they have some information, because I don't remember exactly. Yeah, that's still a proposal, Libby, in Texas, South Texas. So particles collide in the LHC nearly 600 million times per second. The information spilling out of those crashes can tell us volumes about their inner working, atoms, and the forces that hold atoms together. If CERN did record all that information, Atlas, for example, could fill 100,000 CDs with data every second. They can only collect a smidgen of info, enough to put on 27 CDs per minute. And these are just numbers. These aren't images, they aren't songs, they aren't movies. These are just numbers. So that's an alarming amount.
Can I just quickly jump in? You know how they've named this part of it Atlas, this detector? It's kind of slightly confusing, because there's also an Atlas, which is the thing used to detect the comets in space.
Right.
Because you know how we get comets named after Comet Atlas, such and such number. So when I first saw this, I thought, I had to do a double take. I'm like, am I remembering wrong, or is there a thing that looks at comets called Atlas as well? So yeah, I guess there's more than one thing called Atlas, just to confuse us.
Scientists are terrible at coming up with new names. Like they aren't good at it.
They should have just called it bulb or something, you know?
Yeah, for sure. And jump in anytime you want. Like,
oh, thanks, cool. I wasn't sure what the etiquette was, but yeah. I'll try and stay quiet most of the time. But yeah, if I feel like I've got something to add, I'll jump in. Cheers, mate.
No, for sure. If you have anything, I don't mind. So, each day the data center processes 1 petabyte of information. So that's a lot of information. It'd take 223,000 DVDs to hold all the information in a petabyte. To make things more difficult, scientists pour through 30 petabytes each year, which makes new science incredibly difficult to find. And that's one of the tough parts, is there is so much information. So you could actually, I don't know if it's still on Citizen Science Project, but at one point they had where you could classify LHC to help them with it. And Citizen Science Project is a cool thing. If you're into science, you can jump in. I can give them a plug. I have to find it. Yeah, I'll find it later, because I'm not finding it right now. But anyways, they have citizen science projects where you can jump on and classify different things, like stars and stuff. So it's cool if you're a nerd. So 170 computer centers in 40 countries, the grid is touted as the most sophisticated data taking and analysis system ever built for science. It runs more than 2 million jobs a day and can transfer 10 gigabytes of data from its server every second. Without the grid, the Higgs might have gone undiscovered. So, a reference science. Okay, we don't care what you're writing. I don't know if you heard either, Dance. I had a bunch of resources directly from CERN, and apparently their website crashed.
I saw the message that you broke it. It was you. It was no. Yeah, they didn't break it. You broke it.
It might be possible.
Yeah, I mean, I've got a few tabs on my computer I can share at some point, but that's more to do with just one of them, just like a comedy thing about CERN, and the other one is a YouTube video. Obviously, I wouldn't play it, but I watched it the other day. It was just sort of coincidental before you'd sort of talked about these things, or that I knew that you did these streams.
Mhm.
It was let me see now. It was an online University of Oregon. Let me see now. It's from 2009. There's a lecture from somebody called Steve Hsu, HSU. I don't know how you pronounce it.
Okay.
A professor of physics at the University of Oregon, talking about basically the Hadron Collider, a Large Hadron Collider at CERN, and in particular, he was talking about the idea of antimatter and creating antimatter, and he was sort of like showing little bits from the movie Angels and Demons, and talking about the physics side of it, about how some of it is kind of correct physics-wise, but other bits of it are just grossly exaggerated, like the amount of antimatter that they have in the movie and things like that. So it was a really interesting lecture, and I was just, I guess I'm a bit of a geek. I was just listening to that myself one evening while I was just loading the dishwasher. I thought I'll just listen to this, and yeah, lo and behold, a couple of weeks later, I thought you're doing all these science things. I thought, oh yeah, I love all this kind of stuff. So
yeah, I mean, science is always fun. It's it's one of those things that it's just so interesting. Some aspects of it are so interesting, and especially with this, they're doing things at CERN that maybe shouldn't do. So it's really intriguing, and
it's funny you should say that, because on my where is it now? I was just going to put here on my live stream way back on, when they re-switched it back on with the extra power. It says here 5 months ago, so it was about 5 months ago.
Yeah.
I actually sort of said I was a bit dubious. I was like, is this a good idea? I think they were ramping it up to 1.3 something to do with the amount of power or something. And but I made a joke of it, saying it was a great thing, because the day they did it, loads of our politicians in the UK just resigned. So I was like, oh, that's great. If that's the result, then yeah, I'm all for it. Ramp it up to 11, baby. Let's go. So,
yeah.
But yeah, I was a little bit. When they first said they were going to put it back on and at a higher power, I was like, okay, let's see what happens.
Yeah.
hopefully it's not bad.
They TeV is the power electron volt. I can't remember what the T is off the top of my head, but it's a lot of power. Yeah, Dwayne, that's a concern. If we're having energy issues, maybe we shouldn't be doing this either. But if we happen to make a black hole, like, black holes keep eating it, and it could theoretically destroy the entire Earth by a little black hole. So yeah, let's try not to do that.
Ticket 420 just said something interesting. They said that apparently that was about the same time that somebody blew up the Georgia Guidestones when it was back on. Yeah, it might have been. Was it within a day or so?
Yeah, I think that was like the day after. So
yeah, so it's not all bad.
yeah.
But yeah, I forget the unit of energy that they cite. So should we just go back to the future and call it gigawatts? Should we just say
that's
that?
Fine. I think it's tera electron volts. It's TeV,
right.
TeV.
TeV, right? Okay.
So, but what's up, Jessica? What's up, Greedy?
Oh, hi, Jessica. Yeah, thanks very much for when you guys were playing all your fun games and that the other night, and it was early morning for me, I only had a short period of time, but it was great. She just instantly was like, "Oh yeah, here you can be a mod and post your link," without knowing who I was. I was like, "This person's so nice," you know, just on the strength of that you guys knew me. So and that was great fun. I managed to watch bits of that, and Valhalla though, dude, the hangover you must have had after that stream.
Oh, it was bad. It was really bad.
And he was worried about you. That's the irony.
Yeah, next morning, Valhalla was in rough shape, but yeah, Jessica's awesome. She,
he's still trying to make her feel comfortable because he's just put, "Hey Jessica, you're so pretty."
He has no shame. No shame. Yeah, and I'm sorry you saw that. Like we got a little ridiculous at the end there, but it happens. So
that makes for an interesting stream.
Yeah, I'm all for nuclear, but so what discoveries have been made? In 1983, the W and Z bosons were discovered. In 1989, by developing a way for computers to talk each other, hypertext transfer protocol, or HTTP, which we all use pretty extensively. So that was here. And like we talked about with NASA yesterday, there are so many down the line inventions that come from works in places like this. So
yeah, and although I didn't comment on that video, I was listening to that. I was stalking in the background about the NASA one, and so yeah, it was great. I knew obviously stuff like the firefighter equipment and all that kind of stuff that's been developed, but it was a real eye opener. Some of the other stuff that I hadn't thought about that you sort of showed with your research there about the things that have been developed. So it was definitely a worthwhile project, even if some people think it's not worth it. It pushes technology in other ways on leaps and bounds. So
right, and that was more of the obscure stuff. That everybody knows the microwaves, the the Tang, the stuff like that. But yeah, there was a lot of subsequent discoveries because of the space program. So
yeah, like even memory foam, you were saying, because it was to protect their spines and that during the launch, the kind of forces that they go through and all that kind of stuff. It was interesting. It was good. Yeah.
Cool. Thanks. Scientists were the first to create atoms of hydrogen, antimatter counterpart, antihydrogen. So they've been experimenting, to answer your pseudo question that you didn't actually ask. They've been experimenting with different things and running different cycles, but generally it's hydrogen. They obviously stick to the lower side of atoms, lower atomic masses of atoms, just for convenience sake, and to I think maybe you should do a little bit heavier of an atom. I don't know if they can accelerate it, and that might be it.
That was going to be one of my questions for you later, actually, because nobody seems to, in all the articles, they never seem to cite which different types of atoms or combinations of atoms they've tried. And that might be the reason. If they're too heavy, then maybe it's too hard to accelerate them to those speeds. But I was going to ask you that later. We can maybe get into that later.
Yeah, we'll get back to that. So they discovered a new state of matter, a hot, dense particle soup called a quark-gluon plasma. That's getting into the weeds. And the Higgs boson, the God particle, was observed for the first time in 2012. So get out of here, Ad. So this is the kind of information that they get. They get pathways. They get different energy disruptions, and think of it like I'm trying to explain it. Think of it like a wall. So these particles collide, and then they spread out, and they leave imprints on these walls, let's call them, which are detectors and sensors, and they track paths, speeds, mass, and then they look for a consistent data set to be able to build a model of what it should look like. And then since they're not catching everything or processing everything, when something looks different, then they can isolate it and maybe try and recreate it or things of that nature. So it's literally collecting the imprints of the explosion from the atoms striking each other on the wall is the easiest way to think of it. So,
And if I'm right in saying as well, is it the walls are kind of like layered? Like if you imagine lots of layers of paper quite close to each other, so that as the atoms collide and split and things go through, it makes patterns on the different layers, or am I wrong there?
no, you're absolutely correct. And they're obviously different materials, different sensors. They're measuring different changes through different mediums. There's really a lot to, especially Atlas, to because just to see the pathways isn't enough. You have to see the changes in pathways and interactions. So there are different sets of media that it will pass through that can do different things and isolate different pieces of it. So we talked about this in the other article. OHC was completed in 2008, but again, it is not to its max power yet. They increase the power every shutdown. I don't believe it's the next cycle. I think it's the following cycle they'll be at full power.
Do we know what that is in terms of that dev or tev or whatever it was? Gigawatts. I'm just going to call it gigawatts. Because I think it was at 1.3 is the most recent one, unless I'm wrong. But do we know what full power is? What that looks like?
I'm gonna look it up so I don't miscite it. But
yeah, sorry, I should just Google this stuff. I always forget. I've got a second screen every time I forget. I could utilize it. Sorry.
No, you're totally fine. Oh shit, CERN's down. That's why I don't have it. The CERN page is down. That's why I don't have it up. It uses about 200 megawatts of power at peak consumption. Wow, I can't get any information because it's all on CERNs.
I think I just looked at the same thing on Google where it tells you about what it currently uses, but it doesn't tell you what the maximum is.
Yeah, I'm just trying to read in things because I can't click on anything. Tera electron volt. So I was right. Tera electron volts.
Okay, good shout. It needs a dial that goes up to 11. If anybody gets that reference, then you know what movie I'm talking
about. So yeah, and I was right on. I think it's 13.8, but it doesn't actually say in this article. And to think of that, it went from 2010. They achieved collisions at 3.4 TeV or 3.5 TeV. Then they shut it down, upgraded it. When it ran again, it was 6.5 TeV. And then they shut it down, reran it again, doubled the power to 13 TeV. And then to get that last 0.8 TeV is a monumental task. So
is it one of those things where it might be easy to do the first steps, but then it gets harder and harder to get the extra energy? Is it that kind of a curve?
Yeah, it's kind of that. So when you're placing that much energy through it, your magnets. So for example, the magnets will overheat. They're super cooled because that's the only way they can hold the beams. So really pumping that extra energy in for that. Excuse me. For that last TeV is more difficult than going from 3.5 to 13. So
yeah, because you got to make sure it doesn't melt.
Yeah.
So did they use like liquid nitrogen or something? Or I wonder what they use to cool it. I haven't done, obviously you can tell I haven't done a lot of research. Maybe I should.
Yeah, no worries. So they use a couple different things to actually cool it. Obviously, there's the different situations that require different materials because some can contaminate it. But yeah, in the general theory, it's liquid nitrogen around the main ring. When you get closer to the detectors, it becomes a little bit more tricky. So
when the T1000s come, we have to lure them there somehow. Destroy them
absolutely.
with the magnets and liquid nitrogen and all that good stuff.
Yeah. So 12,000 or 1,232 dipole magnets keep the beams, with an additional 392 quadrupole magnets. So yeah, and so they use superfluid helium-4 and also liquid nitrogen. So that's the cooling system. And the magnets are copper-clad niobium titanium. They operate at negative 271 C. So it's a cryo facility, but so mostly helium, some nitrogen. So is what it says. So
With things like this, I sometimes wonder about the quantities of things involved, like whether that's causing any issues for resources, or whether we've got plenty of this stuff. Because I know we've got a bit of an issue with a lack of helium, haven't we? Is
right.
it helium?
Yeah.
Yeah, like as a planet, and yet we still just fill up kids' balloons with it all the time. But I think the concern is it's needed for, is it MRI scanners or CAT scanners? I think it's MRIs uses helium.
MRIs. Yep.
MRIs, yeah. So,
Yep.
but I don't know. This is where I'm rubbish with this kind of stuff. Like, like let's say liquid nitrogen and all this kind of stuff. I don't know about the quantities, but whether if we've got plenty, then fine, just crack on. But yeah, I don't know whether things like big projects like CERN have an effect on that or not.
Well, so liquid or nitrogen, or helium in itself is an interesting thing, because we started producing it and then, or discovering it, whatever, and then the U.S. drove the price down, so it got super cheap. So people started using it. So they built kind of their own. They had a huge supply of it after the war. Then made it super cheap, and now everybody has an expectation that it's cheap. And yeah, but we're running out of helium pretty ridiculously. So it's a concern, and that's why we need to develop new technologies, is to move away from things that we've used up. So it's in this article.
It must still be fairly cheap because they're still putting it in balloons and in people's tires and all sorts of stuff. So
yeah,
but yeah, a bit of a concern if we're just frittering it away when we need it for things like MRI machines. But just my opinion.
and there's different isotopes of it, of course. Helium-3 is a lot of the lunar regolith. Helium-3 can be broken down to make rocket fuel. So that's some of the thought of using the moon as a base, because it would be self-sustaining rocket fuel. So
that's cool.
On a side note, just a little side.
Yeah. Do you mind me asking you some questions, or are you wanting to crack on?
Absolutely, go for it. So
because I was just curious about, because obviously you're quite knowledgeable about this kind of stuff. Was it just because it's always been something you've been interested in, or did you actually study, I guess, in sort of physics and things? Or
I've studied extensively in the engineering side of aerospace, and I've studied a lot of physics and stuff as a result of that. I'm heavily involved in things like the American Astronomical Society, the Astronomical Congress. So I come at it from a space aspect of things. I won't.
I guess that makes sense, because you know a lot about the NASA stuff, and yeah, okay.
Yeah, that's kind of my sweet spot. I've done work for NASA. Not quite ready to dox myself, but I'll tell you backstage what I do. So
okay, cool. Yeah. Don't reveal anything you don't want to.
Chat's not worth it yet. So but yeah, I'm pretty much an open book. So if if you have any questions, for sure. See, I'm getting yelled at by my counsel.
He's probably on several lists already,
Oh, absolutely.
as a threat to humanity.
I also I don't like the chemist. I don't like chemists, but I like chemistry, if that makes sense. So I like to play with materials. If you watch my nuclear science vid, I had show and tell at the end and showed off my cesium and uranium and kind of stuff that I have around.
I just flicked through that one because I was kind of out and about, but I saw that you were wearing some kind of gloves and had some little bits of what I assumed to be some kind of radioactive stuff.
Yeah.
So I thought, yeah, this guy goes hard. he's not messing around.
Some cesium, some platinum, some americium, uranium, the good stuff. So I need some plutonium if anybody has a hookup. You can't get any of that.
Now that you said that, you are definitely on a list. Most definitely.
I'm already on the list. So, but yeah, so at 4 points of the ring, blah blah blah. That's kind of where we're at. So, plan to run for 2 decades. They're actually talking about that it might. Of course, they want a bigger one, is what it comes down to. So they don't know that they can find a sub last on the screen. You're not subbed, Fed? That's terrible. So, so every couple of years they shut it down, rebuild a lot of colliders, improve stuff. They want a bigger one. I know that. So
was that going to be the Texas one, if I remember? Was that the one that might be the bigger one?
There's a couple. Texas, I don't know what. I don't know what the status of that one is. Honestly, that one was supposed to be bigger. There's also the Chinese and Russians are supposedly building bigger facilities. So we'll see.
It would make sense if it was Texas, because I've heard the saying that everything's bigger in Texas. Apparently, that's one. Yeah. Is that a saying over there?
Oh yeah, yep. Yeah. Texas is great. I love Texas. So this is kind of what they look like. These are these sensors that we were talking about. So your beam comes in. I assume everybody can see my mouse. I hate this ad, but you got to deal with it. So the beams are in here, and these particles go out through these sensors to this media. So, okay, good, Fedorowski. So. No, the proposed collider. Yes. So it runs through these media, and then you have all these sensors on the outside here that are collecting data. So, oh, they have it right here.
Yeah, they've got the map right there. Yeah.
It's such a rare process, makes us confident that even in run 3, we could possibly measure Higgs self-coupling. Higgs coupled to 2 others, a trilinear Higgs, is about 20 or 2,000 times less likely than a regular Higgs. No idea why I can't read today. I can't even talk today. Must be CERN messing with me. Things could really start to get exciting after the next long shutdown, currently slated for 26 through 28. During that time, the LHC will be upgraded so heavily that it warrants a new name, the High Luminosity LHC. Over 20 years plus of operating, the machine will work up to generating luminosities nearly 30 times greater than those produced to date, allowing physicists to push the standard model to its limits. So luminosities is just how much information can be obtained through smashing these particles. So,
and you're right. They do suck at naming things, because all they did was put high in before it. I mean, even LHC plus would have been, I don't know, I'm trying to think of any thing that would be a bit better, but just yeah, they didn't really. They had an opportunity to come up with some kind of interesting name, and they've just failed again.
My buddy is I have a good friend. He'll be on the channel at some point, just when we're both free. He's like a legit astrophysicist, and he studies in. His telescopes are in Chile, like the ones that his institution uses, and he's named over 10,000 stars, and he just names it last name and a number. I'm like, dude, you got to get more creative than that. So
I remember you mentioning him on one of your streams, because I was joking saying because you sounded like you described Sheldon Cooper.
Oh, that was you? Yeah.
Yeah. But yeah, I mean, if he's willing to come on stream sometime, that'd be interesting to see what he has to say.
Yeah, he's a good friend, and yeah, he is pretty much the embodiment of Sheldon Cooper. He is super awkward but incredibly intelligent. So, but ultimately, this would be a more powerful collider that would be 100 kilometers around. So that's pretty intense.
It's about what 60 miles or something like that.
Yeah, 66 miles, 63 miles, something in there. So booster ring for the FCC. Future Circular Collider. What a great name. The FCC. Jesus.
Hang on, isn't that the thing that regulates the TV or radio over in your country?
Yeah.
The FCC won't let me be.
Yeah.
So now we've got 2 Atlases and 2 FCCs. They're really not helping us, are they?
No, not at all. And yeah, the LHC at that point could be a booster ring or a decelerator. So as far as them creating, we've touched on it. I don't care who you are. We've touched on it. The amount of antimatter that they made was incredibly small, and it was seconds, because antimatter, for those who don't know, when it contacts normal matter, it explodes and fiery goodness, and they annihilate. The particles annihilate. So it's pretty incredible that they got it that long, but they have collectors, and they trap it essentially into the collectors for study. So
that was a bit the that YouTube sort of lecture that I was watching was talking about about how when the antimatter and the matter, so basically it's exactly the same, but the charge is the opposite. So when they come together, they kind of annihilate each other, but they produce energy at the same time. Yeah, so that's why it kind of creates the explosion.
Right. Yeah, explosion is that's, I hate to say dumbed down, because it's not dumbed down. It's the dumbed down version. I can't think of a better way to put it. So, but they annihilate and turn into energy. So if we could ever harness antimatter, which they say there's as much antimatter in the universe as there is matter, I have a hard time with that one conceptually.
Wasn't the theory as well that actually there had to have been more matter than antimatter originally, because there was a lot of this colliding and annihilating of each other going on, but what we've ended up with matter, there is matter in the universe, so there must have been an offset. Like, it wasn't, if it was equal parts, you'd end up with nothing. This was just a theory from one of those lectures. This isn't my opinion, but I wonder what your thoughts on that were.
I think that there has to be considerably more matter, and actually the prevailing theory is there's more antimatter than there is matter, which doesn't make sense, because
we better keep our distance from it then,
right?
Then it can stay over there. I don't want to get near that.
I think that if anything, either there was small amounts of antimatter, or that they were equal, and there are different, not dimensions, but different regions of space that have antimatter, that we probably wouldn't want to hang out in. So it could go very, very badly.
With you mentioning the word dimension there, that's probably a whole nother video for a whole nother talk.
Yeah.
So I have some theories on that might differ from other people's, but even physicists will say that they believe that there's X amount of dimensions or what have you. But
Right.
yeah, but that would be, I don't want to derail it from CERN. that would be a whole nother video.
We got plenty of time. We can talk about all this stuff. This is my wheelhouse. So science, I love it. So I'm trying to proof this a little bit. So this is another example of how they see a particle. And interestingly, MRIs are kind of, well, actually not MRI. Well, I think it's more CT. I don't know much about the medical field, but I know one of them came from this kind of theory. And basically what it does is it rearranges the proton. It's got to be MRI. So it rearranges the protons in your body, and they shoot out beams either side, and they can topographically map based on the beam shooting out. And that's how they can build a picture of your insides without going inside. MRIs are fascinating, but
have you ever had one, by the way?
An MRI?
Yeah.
I'm claustrophobic. I'm terrified of them.
Oh, sorry to hear that.
but yeah, I have.
Just as more of just an anecdote, but when I went to have one of those, it was actually the second one. But so she's giving me the spiel about how it makes all these noises and stuff, and I was like, yeah, it's fine, it's quite pleasant. And she looked at me funny and she was like, pleasant? I was like, oh yeah. I said, well, I live at home with 2 young children, both girls. So to me, just sitting in there with the headphones on is bliss. It is pleasant to me.
Yeah.
Yeah,
it's not that bad. It's loud, but it's not that bad. So.
You kind of almost feel it as well when it's doing the. It's. I don't know if you did, but I could kind of. You feel like it's doing things to you. You know, obviously it's lining up things within your body, but I mean, not in a bad way, but just maybe I was just overthinking it because I know what it's doing.
Yeah, I mean,
I found it fascinating.
But yeah, I mean, it's taking the iron in your blood and rearrange. So, I think that with its it's high magnetism. I think that you should be able to feel something like that. But yeah, I think we often project what we know onto how something's doing. So, Alec Gringer, I am a very big guy. I have massive shoulders, unlike Ricada. Like I cannot fit through a door like a normal person. Like I have to turn sideways because my shoulders are huge. So they are so incredibly tight for me. So even closing my eyes, I just feel like I'm getting smushed. So sorry. Side note.
Hopefully you don't need any more MRIs then, particularly if you've got claustrophobia.
Hopefully not. So this is another image. This is a simulation image, just kind of how it looks. So you have proton coming in, smashing, and you have all these particles, and they get picked up at various areas in this medium. As you can see, it's kind of like a mesh-ish medium. And then you have further detectors out here, and different isolations and stuff like that. So it's pretty interesting. So it's colder than outer space. 1.9 Kelvin. That's another thing. They would like to get it down to zero, absolute zero. So cryogenic cooling. 200 billion protons around a 27-kilometer ring at the rate of 11,000 times a second. So just unfathomable. 11,000 times a second around a 27-kilometer ring is just something we can't comprehend. So there's not even you can't even make a comparison with speeds like that. It's insane. So
the way this, I don't know if it was just what you said, or I think it was what it said in the article before, but it said about proton smashing. It just made me think it's effectively proton porn with all these cameras looking. Makes it seem a bit seedy.
That's a terrible image in my head.
Yeah, sorry, I think I've ruined CERN for you now for good. Sorry.
And there's, I believe that, Jonathan. What's up, man bun? I haven't seen you until now. Sorry. So Higgs was supposed to be the great particle, and they found out that there's a lot more to it than that. So kind of disappointing, but also, and we talked about this the other day. We're still at least 95% ignorant. We don't know much of anything. Even after the discovery of Higgs, the standard model is not complete because it only explains 3 out of 4 fundamental forces work, omitting gravity. I have a very interesting take on gravity. I might be able to get another person on. He's not as camera friendly. That believes he's a scientist out of University of Colorado, and he is looking into a replacement of gravity with electromagnetism. Doesn't believe that gravity is Newton's gravity like we think it is. Very interesting paper if you want to read scientific papers. Well, gravity
is that more of a theory? Sorry, I was going to say, so is that more of a theory of the forces are more like almost like the way electromagnets work? Because I suppose everything's got charges. I don't know. It just, I'm thinking of something else now. I'm going off on a tangent. My brain will do that. But there was a thing about how like everything has a kind of like frequency in terms of sound frequency, and technically, I suppose if we mastered that, you could move heavy objects by using sound waves and things like that. But that's far out sort of theory. But right. I wondered if your friend's theory on gravity was something. So he's basically saying he thinks it's slightly different to what the conventional thoughts are. Is that his take? That it's something different?
For sure. He thinks that's in large part, to oversimplify it, that even non-magnetic or non-ferrous metals have magnetic interaction. Beyond, so kind of gravity's gone, and we contemplate the strong and weak nuclear forces as magnetism, as aids to magnetism. So yeah,
Dwayne just said in the chat, gravity cannot account for star formation. Right. I don't know much about that, but I guess is that part of the problem with the conventional theory of gravity? It doesn't. There's some things that it still can't explain.
Correct. Yeah.
Right.
Because you wouldn't continue to collapse in the way that you would need to in order to, like, the particles themselves wouldn't crush themselves so small to create stars. So stars, and we don't really know how they, like, we haven't seen a full process of one, because on the cosmic time scale, we are very small. We've been, seconds, and haven't seen a full formation of a star. We can see back and see different phases, but one star start to finish. So they basically get super cool, stop moving, particles stop moving, and they crush into such a compact nature that they explode and start fusion. That's how a star forms, that we know of. If that made any sense.
I'll have to take your word for it. Okay. I mean, I've got different takes, but that's only. But I'll admit my biases. That's more to do with religious beliefs. But I'm always open-minded to discuss things. And in terms of star formation, I'll have to take your word for it. I know literally nothing about it.
Yeah, and I think that would be an interesting conversation if you ever want to have one. How we can intersect with that. the religious aspect with the science aspect. So
yeah, absolutely. Again, that would probably be a long one, but there was an interesting YouTube video I saw once, which was about how if it was something to do with like a massive gravity force, and if no, I'm not going all into it, but it was basically sort of showing a way in which things could appear a lot older than they actually are, and all sorts of stuff like that. But yeah, no,
gotcha.
That's maybe for a different stream. Sorry, is my camera sometimes glitching a bit?
I haven't seen anything, but
oh no, okay, I'll keep an eye on it. but yeah, no, that's I know this one you want to obviously keep centered on CERN, so I'll try not to pull it away too much.
no,
and then
no problem.
there is a funny little bit of video. It's about a minute long. I could show you about a comedian talking about CERN, but I don't think it would have any copyright issues. But obviously, I would only share that if you're okay with it.
Yeah, I don't have a problem with it. So they already hate me, so it's not a huge deal. You want to? I think you have buttons. Do you know how to do it?
I should be able to present if I get it on this screen. Have you heard of Bill Bailey, the comedian? You might not have heard of him because he's British.
Not right off the top of my head, but why don't you share that, and then that will give me time to scramble and find what I'm looking for over here.
If I just click this here, screen to share, and that should give you a chance to. There we go. I think the sound is on. So if I just play from about here, I'll just give it a few seconds and see if it works.
Okay. Yeah, I hear it, but can you turn it up a little bit, or is it all the way up?
I think it's on max.
Under Switzerland. That is quite a large margin of error. Nothing. Switch it on again. Switch it off and on again. To apocalypse. Everything. Shoot. All the Toblerone. Shoot.
I'll just pause it there, but I just thought it was really funny. I remember I was actually at one of those shows he did when he came to Newcastle nearby, and he did that. Oh, hang on, I should stop. How do I stop presenting that then?
Oh, here, I can do it.
Oh, you do. Oh, okay, you do. And he talked about that, and I just found it funny because it's like, yeah, it was literally either nothing could happen, or we could destroy half of Switzerland. That's why when they were ramping it up, I was thinking, is that a good idea? Should we be doing that? Oh, there we go. I'll stop screen. There we go.
Yeah. I'll throw mine back on.
I mean, that was years ago. It was like 11 years plus ago that he said that. But he's a funny comedian. I was Tigger 420 saying, "I love Bill Bailey." Didn't know he
look him up.
Things. Yeah, he's actually quite intelligent. Is Bill Bailey? Some of his comedy stuff. He even did a bit about Stephen Hawking's A Brief History of Time and stuff like that. Quite a clever dude.
My favorite book ever.
Well, Bill Bailey does a skit where he's talking about like this stuff, and then time is relative, this, that, and the other. It goes off for about 3 or 4 minutes, and he goes, and that's just the title. I haven't even got off the title, and already I'm confused. And he was kind of joking. He was sort of talking about Hawkins, like when he was reading through the book. There's bits of it where it's almost as if, sort of paraphrasing, that Hawkins is just going, well, God probably did it. Yeah. Bill Bailey's like, wait, what?
Right.
Yeah. Oh, my camera's definitely glitching a bit here, but I'll have to.
Yeah, I'm glitching. I gotta hang out for 1 second. I'm gonna jump out and jump back in because I can't get to anything. So
okay, yeah,
I'll be right back.
Hopefully, me being here won't eat the whole stream, and hopefully it keeps it running. And I think he's muted me. Can you guys hear me? I'll ask the chat. Muted. Wait, can you hear me? Okay, it sounds really weird as if it's not working. So, Mighty Meat obviously trusts me. No, there's 2 Mighty Meats. No, we don't want that.
There we go.
Good grief. For a minute, I thought we had 2 of you, Mighty Meat.
We did for a second. That was scary. So,
Cool.
yeah,
The sound
sorry
of my
about
ear
that.
went really weird, so I thought I'd lost them, but they could hear me apparently.
Okay.
Yeah. Good to have you back.
So,
And very
here's a
trusting
little-
of you. Very trusting. I didn't say all the slurs all at once.
Who cares? I'm a free speech advocate, so
Cool.
say what you want.
I'll just say as well, I'll probably have about another 15 minutes or so, then I'll have to actually drop out. But
All right.
yeah, I can stick in for a bit.
Okay, yeah, just let me know. Just don't feel obligated to hang out. So I'll probably. Ooh, mine just switched too. I'll probably wrap up there too. I was going to go through some detectors and then call it a day. So it has 4 large detectors on it: Atlas, CMS, LHC, B, and Alice. And it actually has 5 small detectors: Totem, LHCF, Modal, Phaser, and SND at LHC. So there are several different. They'll actually, like I said, focus that beam, crush them, and they will. See, I stopped using smash because you said that. Crush them, and then
No,
they'll run into each other. So,
they must have multiple detectors at each point because there's only, if I remember right, there's only 4 crossover points.
yes.
So if they've got this many detectors, I guess there's multiple detectors at each crossing point.
Yeah, and there's several that work in tandem or work off the information that the one sends and stuff like that. So, this is a great site, but it's there. We go. We can do it that way. So this is kind of what you're looking at, a little bit better. So this is kind of what we're looking at. A traverse slice through the CMS. So you have all this different media to collect information about what's going on. So there's iron muon chambers, there's the superconducting solenoid, hadron calorimeter, whatever, EM calorimeter, and the silicon tracker. So goes through the silicon, and obviously when particles are going through different media, they're slowing down. So, and this shows you a little bit of what the photons only get to this far, electrons get stopped here, muons keep going forever. Yeah. And that's the other thing. They rapidly decay into lighter known particles. So
how far do morons go?
What's that?
Sorry.
Where do the morons
go? How far do the morons go?
They're everywhere.
True.
So that's the other thing is they only have, fractions of milliseconds to see these particles, and that's the important part. Is they're moving quickly and they're decaying very quickly. So blah blah blah, protons, neutrons fly the detector at close to speed of light, and we have to see this, we have to capture this and see this, and that's tough to do too. So here's another breakdown. So of what it kind of looks like.
I think, if I'm right, I heard that obviously there's nothing that can really detect it visually. It's so fast, it's too fast. So it's all data, and then the data has to be computer generated things to show what it looks like. Is that right?
Yeah, that's absolutely 100%.
I have to dumb things down because that's the only way my brain works.
No, I try to, and then I'm like, oh, I don't know if I explained that. So yeah, so this is petabytes of data that they put together. This is, I don't know the exact, but we're talking about microseconds and fractions of microseconds all this information is right there. And
it's actually just a screensaver, and they've just taken all that money and just gone to the pub. So that,
at least have it.
Yeah.
I mean, I would.
If you put in the thing for the funding for what you need, just double it. So
right.
you've got enough for the project and loads of beer at the pub.
Right. I just realized that I was gonna type something.
Sorry, I'm really good at derailing you, aren't I? Sorry.
No,
you're trying to actually make this informative.
I'm so good at derailing myself that any additional is just. Anyways, so this is an easier breakdown to read, and you have the photons, electrons, positrons, muons, hadrons, neutral hadrons, and neutrinos. And this is how far they make it, what they look like, what they expect, and they're looking for things outside of those hadronic and electromagnetic kilometer. I'm going to call it kilometer because I don't know how it's spelled or correctly pronounced. So there's a lot of information in there, but they're also looking for these muons, the quarks, the different things that are outside of that normal range. So, and a lot of it's inside this earlier part because then they're gone before you know it. So,
quarks. Just to back up slightly, quarks are the like in a proton and a neutron, they're made up of even smaller things. And is that right? Is quarks one of those?
Correct.
Yes. So when they're smashed into, sorry, I shouldn't say smash, should I? When
yeah, you wrecked that forever.
I know, I really did. so when they're hitting each other, it's just as bad. Is what's going on there? It's so powerful, obviously, that it even splitting into individual quarks and maybe less, or is there still stuff that we don't understand?
Well, the quarks and muons, that kind of subatomic particles, there's something smaller than that because they still have mass. So there's got to be something smaller than that to make up quarks, if that makes sense.
Yeah, and I guess we have limits on how small we can detect, and yeah.
Well,
so, yeah.
Even with our best computers, we can't. The time is the issue. They decay before we can.
Oh, because they're no longer stable. So yeah, they just it's a fraction of a second and they're gone. Yeah.
Right, because they want to be in their highest stable state. So, by nature. So, and then they do stupid things like LS is a long shutdown. Like, come on, man. So this is where. This is a better understanding of kind of where it is. The LHCb. So you have all these detectors, all this stuff. There's also CMS. I guess I could read these. Alice, several detectors have been replaced, so the experiment will receive data at 100 times the previous rate. Oh, this is the updates. I was like, what?
Alice, I guess this is listing what they did during the shutdown. I guess is it all the upgrades they did? Is that what?
Yeah. So muon small wheel detectors have been replaced, and upgraded data acquisition systems will spot a wider range of events. So muons go through everything. So it's a wheel to kind of recirculate them and study them a second time, see if they do something. So. LHCb electronics and detectors have been overhauled to cope with the faster data rate. So they just made better computers.
Yeah, they've had a processor upgrade effectively.
Yeah. Prototype detector layers will test the capture of muons, heavy cousins of electrons, at higher rates. Upgraded electronics will improve energy measurement for hadrons, particles made up of multiple quarks, such as protons and neutrons. So, in English, quarks make up protons and neutrons. So they're the building blocks of. And one of the interesting things is, are all quarks the same? If you have because there's delineation at an atomic level, but that's mostly because of the neutrons. How many neutrons and electrons there are. So is there any, would a steel quark have a different makeup or value or properties than a hydrogen quark? You know, it's just where my brain goes. Sorry, nerded out there for a second.
No, I understand what you're saying there. Although, if the quarks are part of a proton or a neutron, they're the same in every atom. It's just the different numbers of them makes up the different atoms. So, wouldn't all the quarks be the same? Or well, this I guess is what you're asking. Are they all the same, or are there differences depending on what thing they're making up?
Right.
I guess the only way we can figure out if all quarks are the same is to go into Star Trek and ask Mr. Quark.
I think that would be easier than building a bigger collider, honestly. Excuse me. Yeah, I know CERN website.
Just thought of something as well. You were saying about your friend and his theory on gravity.
Mhm.
Am I right in thinking? Again, I'm trying to sort of think of it in my sort of dumbed down way, but gravity doesn't work in the same way on the microscopic scale, on the atomic level, as it does to our level, and then again in space and large things like galaxies. Is it the gravity kind of acts differently depending on what scale you're at? Is that right? Like it doesn't act in exactly the same way on a subatomic level, or am I wrong?
No, quantum physics doesn't play well with gravity at all. It doesn't make, well, to be fair, quantum physics doesn't play well with anybody, but especially gravity. Like it doesn't fit that model. So
So that's like an unanswered question that they've got. Is it one of the mysteries?
Right.
Okay.
Hang on before you go and type in something. You know how to get the backstage chat, right? The private chat at the bottom.
Oh yeah. Okay.
That's what I do. Part of I agree and disagree with you, Dwayne. I think it's important that we find, but I still believe in simulation theory and that we can't find. We don't have all the information. Did you see that thing?
Yes, yeah, that's cool.
Okay.
Yeah. Okay. Cheers, thanks for that. I've made a note. Yeah.
So that's what I do. Proton synchrotron booster.
What Mighty Meat just told me is that he's a Baldo sculptor. He's sculpting new Baldos.
And test pilot.
And test pilot. he's going to test them on Nick.
Yeah.
And Hayden. Yeah, that's an image that nobody wants in their head. I think I've ruined everything now.
Pretty much. It's time to go, isn't it?
Yeah. No. I'm surprised you haven't kicked me out now. Yeah.
No. So yeah. I wanted to try and check CERN's because there's limited information because CERN has such an interesting database for it, but there's not with their website down. It's difficult for sure. So I really appreciate you coming on. I know you got to skate out of here. You're welcome anytime, man. We have some interesting stuff coming up, and in the night show, we're going to talk a little bit more about the conspiracies about it, the rituals, the stuff like that. So
I would love to get into that with you, but I think the time difference means that's in the middle of the night for me. I think.
Okay.
But yeah, I think we've barely scratched the surface of subjects that we could talk about. So I hope in the future I get time to. The only thing with me is that Tuesdays evenings is usually when I take my daughter to my eldest one to. I'll just say soccer because you'll understand what I mean if I say soccer.
Yeah.
So I'm not usually in the house. But yeah, anytime I can sort of join you for a stream, particularly if it's a science one, I'd love to jump in anytime.
Okay. Yeah, and like I said, kind of my wheelhouse. I'm probably going to switch to doing Thursday stream. It's Thursday science too. And in the long-term plan in the new year. So, but yeah, I appreciate you having me, or you joining me here, and anytime, man. You're always welcome. So,
Cool.
you want to
Thanks.
show your channel or grift for a minute before you go?
Yeah, if you don't mind, just
Yeah.
just YouTube /dancebikerdance. You should be able to find me on there. All I do really is just there's some old videos of me just doing stupid dances in my leathers. There was one called where I did a parody of Wrecking Ball, where I was wearing literally nothing but the helmet, the gloves, and the boots, swinging around on a big wrecking ball. But I had to recently private that one because my daughter, who's 14, was like, my friends at school are starting to see it. Make it private now. Make it private now. So, yeah, that one's not there anymore. Apart from that,
I'm
just
sad I missed
screaming
that.
I might have to send you it privately, yeah. But yeah. But yeah, but obviously sub to Mighty Meat, sub to Valhalla, just sub to everybody.
Yeah.
I'm loving the content you're making anyway, so you guys. So I'll say goodbye. I'll duck out of here so that you can finish up your stream. But thank you so much for having me on. It's been great. It's been a blast.
Yeah. Thanks for coming on, brother.
All right. Catch you later.
We'll talk to you later.
Bye.
And that is Dance Biker Dance. Go ahead and give them a sub. You know you want to. So that is, send me a link to my phone. A link for the show. Wow, nobody knows what you're talking about. Just text me, bro. Never mind, disregard my name. Okay. I was going to anyways, so we're on the same page. So that is it for me for the day stream. We are going to... Oh, you're good, brother. We're going to pick this up from here and, like I said, dip more into the conspiracy angle, some of the rituals, some of the things surrounding it, logo, stuff like that, with Val at 8 o'clock. Until then, you guys have an awesome day. I love you all, and we'll see you soon. Take care and have a good one.